Hello guys, in today's video we are going to learn about a popular programming paradigm called divide and conquer. But before getting into the action, let's match our expectations. I'm studying this topic by myself, and my videos depend on the wisdom of the crowd, a topic that really fascinates me. Therefore, if you find any mistake in what I say, please let me know in the comment section below. I promise to read all comments and re-upload if necessary. Also, please subscribe to my channel. I tend to upload many videos on this topic. Algorithms designed by the divide and conquer programming paradigm consist of three parts: divide, conquer, and combine, not necessarily on this order. Divide. The algorithm breaks down the problem into smaller subproblems. Conquer. The algorithm solves all subproblems. And combine. The algorithm combines the solutions for all problems to solve the problem we inquired about in the first place. A simple divide and conquer algorithm is the merge sort. Let's look at it. Alrighty, merge sort. Given the unsorted array 19, 2, 10, 7, 1, 0, 4, and 3, sorting it using a naive algorithm would require n to the power of 2 times, because each individual variable in the array requires n work, because we need to compare it to all other n-1 variables. We would use a divide and conquer algorithm, merge sort, to reduce the computing time to O of n multiplied by log n time. Let's see it. We would divide the given array into two separated arrays with an identical length on each iteration, plus minus 1. That is because it is possible that n equals to odd number, and therefore we wouldn't be able to divide the array into two separated arrays of an identical length. Anyway, once we are doing this, we would divide the subarrays into another subarrays until we are reaching separated arrays of the length of 1. This stage of the algorithm is the divide part. As you can see, the algorithm required log n steps to complete this stage. This is because log 2 of 8 equals 3, and as you can see, we required 3 steps here to reach 8 separated arrays of the length of 1. In any case, we would now sort and combine every array and double its length on each iteration. So we have here, for example, the arrays 19 and 2, and we would compare these two variables, and we are getting an array of the size of 2, which the left variable is 2, the smaller one, and the larger variable is 19 on the right side. And we are doing the same to all other arrays. After we done this, we are repeating the process until we reached 2 separated arrays. Anyway, this stage of the algorithm is the conquer part. It is reasonably quick because we know on each stage that the most left, smallest variable is one of the variables which is also the smallest in its respective array. And after we found it, we can move forward, always comparing two remaining variables which remained on the most left side of their respective arrays. Let us see it in action. Now we have two arrays. The first one is 2, 7, 10, and 19, and the second one is 0, 1, 3, and 4. On the first stage, we are going to compare the variable 2 to the variable 0. And of course, 0 is lesser than 2. And we are going to eliminate it and place it on our array. Next one. Now, after we eliminated 0, we are going to compare 2 and 1. Again, 1 is lesser than 2, and therefore it is going to take the next spot. Moving forward. Now we are comparing 3 and 2. This time 2 is smaller than 3, and therefore 2 is going to be eliminated, and take the next spot. Moving forward, 3 is smaller than 7, therefore it is going to be eliminated and take the next spot. 4 is lesser than 7, therefore 4 is going to be eliminated and take the next spot. Now, as you can see, the right array was completely eliminated. And of course the left array is already sorted. But just to repeat the process and make it more clear, we're going to compare 7 to 10 and 10 to 19. 10 is smaller than 19 and it is going to take the next spot. And finally, 19 is the final variable which we haven't placed in our array. And there we go, we got a sorted array. Perfect. This was the combined stage of the algorithm. Each merge process of the O log n processes we had required O(n) time, comparing two variables, O1 n times, for a total of O n multiplied by log n time. Well, that's about it. I hope you learned something new from this video, and please comment below with your thoughts. First degree studies in university are all about social studies, and this project comes to encourage that, even through complicated situations most of us are going through right now. Please subscribe to my channel. Until next time, good luck!